Welcome back, guys. Last time we discussed a search heuristic that was using semantic information about the effect of propagation. Today we're looking at another one, activity-based search, and it is also a semantic strategy. So let's take or semantic heuristic, I should say. So let's take a look at that. Activity-based search, the main idea is that we'd like to see how often a variable gets contracted when we're searching. That is, how often it's involved in a fixed point computation and it loses value. Because this is going to actually tell us where we should focus our activity when it comes to selecting a variable. Because the variable whose domain is often contracted is necessarily a good candidate to branch on early in the search and have as much impact on shrinking the search tree. That's the basic idea. Now, how do we do this? Well, it's not too difficult. It's a little bit of statistics to maintain, as always. But each time a search choice is created, we're going to increment a counter AX for the number of activity engagement for variable X. That's the activity of variable X. And it's going to tell us how often we have contracted. So if we start with the CSP XDC and we make a decision X equal A. So this is our branching decision. We're going to get to a new node where we have a subset of variable X prime. This is a subset of the full set here. The subset of the variable that have experienced value loss. The domain of these guys have contracted. It's clearly a subset. And what we're going to do is that once we are reaching the fixed point here, we'll say that first, every variable that has more than one value left, right? This is the condition, more than one value left. I should, just like in impact-based search, progressively forget about the past, about its past level of activity. So I'm going to age the activity of the variable by multiplying by a parameter gamma. Again, gamma should be between 0 and 1, and if it's close to 1, like 0.95, you're going to progressively forget the past. If you were to make it 0, clearly you don't have any memory, right? It's Dory the fish. You're forgetting everything about the past. Whereas at 1, you're not forgetful at all. You keep everything. Now, all the variables that were impacted by the fixed point, that is the X prime variable, every single one of these sees its activity counter tick up by 1. So one more engagement in a fixed point. That's good. Notice that we don't try to capture how much shrinkage. We only capture how much engagement we're getting for that variable. And then our variable selection heuristic is going to be straightforward. We're going to be maximizing the level of activity, and we divide by the size of the domain. That is, once again, if a domain is small, that will barely reduce. If a domain is very big, well, it will take a hit. We will consider it less active. So we're still taking into account the domain. Remember that in the past, the domain was on the numerator. That's why we were minimizing. Here it's on the denominator, so we're maximizing the ratio, activity divided by domain. And this can actually prove quite effective for determining what to do next. Now, of course, those of you who pay attention are thinking like, what are you talking about? How do we start this? What is the activity at the beginning? Well, the activity at the beginning, you could say everybody is inactive. Activity 0 for every variable. That sure would work, but that doesn't give us very much information because 0 divided by anything is 0. And we don't even use the domain size. Okay, maybe we should start with an activity of 1 for everyone. That's another option. At least now we're using the domain. But fundamentally, isn't there a better way? And there is, both for activity as well as for impact. It's to initialize with a technique known as probing. So let me explain. What you see on that picture is that there is a search tree, blue. We haven't explored it yet. We're at the root. But what we can do is that we can follow these trajectories, right? And this is a trajectory, this is a sequence of decision, and we go down the tree and we follow a path. And you see that this snake is almost like a random path. And that's right, it's not almost, it is a random path. We're basically going down the tree, making random decision and measuring the activity along the way for this path. It will end at a certain depth when we have an inconsistency, it might even end up on a solution, in which case we've solved our problem. But if that happens, we go back to the top and we do another random walk down a path in that tree. And the whole idea of these probes, each path is such a probe, the idea of this probe is to sample the activities throughout the tree and initialize A with some value. Notice that as we do that, we don't need a heuristic, because we're basically doing random decision as we go down, but we measure the activity anyway. After doing that for a few seconds, we're good. Go back at the root and start using your activity to guide the search. That's the basic idea. It works extremely well, and it could apply to other techniques like impact-based search as well. With that, I'm wrapping up on that second semantic-based search strategy, and I'll see you next time to look at some other interesting topics. Still on the variable selection though. Bye-bye.